Okay, this is a graph of life expectancy. The graph below shows the life expectancy of people born between 1900 and 2000, where the vertical axis is life expectancy and the horizontal axis is the year that you were born. Now, on your sheet, it came out a lot better than this. It's a bit bigger and all the rest of it, so you should be a little bit easier than with me. The first question is nice and simple. What is the life expectancy of a person born in 1932? So it's just about reading 1932, heading up here, and I think from memory the answer is 60. Oops. The answer is 68. With reference to the gradient, explain what the gradient is showing us in this scenario. Okay, so the gradient is the rise over run. So the gradient, it's gone up 10 years and it's gone across 40. All I've done there is I've picked this dot that's on a really nice spot, this dot that's on a really nice spot, this dot that's on a really nice spot. In other words, it's where there's whole numbers. Every 10 years here, the rise is 10, the run is 40. Here, the rise is 10, the run is 40. Remember, the gradient is the rise over run. So every 40 years, the life expectancy goes up 10 years. That's exactly what the gradient's saying, or the gradient is a quarter. So up 10 years, the rise over the run is 10. Rise over run is 1 over 4 or 10 over 40, or every 40 years, the life expectancy goes up 10 years for that person. What would be the equation of this line? So let's have a look at this. Remember, from B, we know that the rise over run was 10 over 40, which is a quarter. So we know the gradient is a quarter. That's from part B. The next thing we need to know is we need to understand that every single straight line can be written as y equals mx plus c. In this case, we already know what the m is. The m is the gradient. So the m is a quarter. But we've got all these other points. But we also know that, in 1940, your average age is 70. So when y equals 70, x equals 1940. So we can say that. Okay, so when y equals 70, x equals 1940. Let's substitute that in. So we know that 70 equals a quarter of 1940 plus c. What's the obvious next step is to find a quarter of this. So we get 70 equals 485 plus c. So c must be minus 415. So this c must be minus 415. 485 minus 415 gives us the 70. So what is our equation? Our equation is age expectancy equals 1/4 of the year you were born minus 415. And that would be the answer. If you wanted to have it or put it into, y equals 1/4 of x minus 415, that's fine as well. Either way there would be perfect. So there's two options, I guess, with your final answer. The last question, explain why or why not this relationship may or may not be extended past the boundaries of this graph. Well, going out this way, it sort of means that at some point we'll be living forever. And maybe that's the case. Maybe back in 1900, people had an average life expectancy of 60 and thought, oh, no one will ever have a life expectancy of, 80 or 90, but we're there at the moment. So we could maybe extend it out here. It does seem that, by the year 2050, life expectancy might be 110, but who knows? With health, that may be the case. What would happen going the other way, though? If you consider the year 1600, if you put 1600 into this formula here, 1/4 of 1600 is 400. So your life expectancy or your age expectancy, life expectancy would be a better word there, would be 1/4 of 1600 minus 415. Basically, that's saying that you would die 15 years before you were born. And that just doesn't make sense. So for years like 1600, 1700 would be, the average life expectancy would be about 10. So for certain years outside this realm, it doesn't make sense. Thanks.